Okay, so this video is meant for my geometry students. We have a quiz on Monday covering sections 9.1 through 9.4, and here are some problems that you might want to be familiar with. Alright, so the first problem here, you might want to draw this picture. We're going to identify the similar triangles in this. Now notice you have a big right triangle and then an altitude drawn. So you have three right triangles and they're going to be similar to each other. Alright, so the first triangle we'll look at is the big one. And again, alphabetic order, triangle W, Y, Z. W, Y, Z. And in this large right triangle, I'll call WZ the long side and YZ the short side. Okay? So we'll make that distinction. They are kind of close, but WZ is going to be the long side. Okay? And then we need to label the other triangles. So here in this triangle, let's call this the long side and that the short side. So for WYZ, W down to Y. Okay, so W was between the long side and the hypotenuse. And we went down the hypotenuse. So we have to find the same point here. And that same point here is W, between the hypotenuse and the long side. Okay? So W, and we go down the hypotenuse to Z. WZ, and then we finish off with X. That's going to be similar to triangle, and now we look at the other triangle. And again, I'll label this the long side. Remember, the altitude is one of each. XY is the short side. Okay, and we need to start with the point between the long and the hypotenuse. That would be Z here. We go down the hypotenuse to Y, and then finish off at X. And here's the similarity statement for the three right triangles in this picture. Okay, and now we'll pick up a second part. We have to find these three lengths, WZ, YZ, and XZ. Okay, so notice that WZ is a leg, YZ is a leg, and XZ is the altitude. So we have a leg. I'll do this in different color. We have a leg, and the altitude. Okay, so first let's set up a proportion to find WZ, the leg. The leg is going to be the geometric mean between the entire hypotenuse and the part of the hypotenuse that it touches. So in my proportion for WZ, WZ goes in the means spots. I use the entire hypotenuse, which is 14, and then the part of the hypotenuse that touches WZ. Well, WZ is here. So the part of the hypotenuse that touches it is here, and it's labeled as 10. And I can find WZ by doing I'll cross multiply. So we got WZ squared equals, I will not multiply, 14 times 10, and then I'll take the square root. And WZ equals the square root. We'll break this apart as 2 times 7, and 10 is 2 times 5, and the two 2's will come out as 1, 2. Those 2's go away. 5 and 7 cannot break down. 35. Okay? And there's WZ. All right. Now I want to find, I'll use pink. I want to find YZ. Again, YZ is a leg. It's right here. Now, in order to find YZ, and notice YZ is going to be in the mean spots. To find YZ, I need to use the entire hypotenuse, 14, and the part that touches YZ. Well, here's YZ. The part of the hypotenuse that touches it is XY. Well, I don't know it, but I do know WX is 10. I know the entire thing is 14. 14 minus 10 is 4. There's XY. So we cross multiply. YZ squared equals 14 times 4. We take the square root of both sides. YZ equals the square root of, and I'll break this apart, 2 times 7, 2, and 2. For every two 2's, a 2 comes out. So YZ equals 2. Cross those ones off. And then the 2 times 7 does not simplify, so we just put 14. Okay. And lastly, the altitude XZ. Okay, I'm going to use blue. It's kind of hard to see here, but it's the geometric mean, so it goes in those two spots. And XZ is here, and when you do the geometric mean with the altitude, it's the parts of the hypotenuse, 10 and 4. We cross multiply, take the square root, and we get 2 times 2 and 2 times 5. And of course, 2 2's bring out 1 2. The 2 and 5 do not simplify. You get 10. So there is a great example, and you should definitely know how to do a problem like this. And I think these are the toughest problems. Okay, so here's our next problem, and we'll do 2 of them. Find the missing length, and we have right triangles. We have 2 of the 3 sides. We need to find the missing length. So for each triangle, we'll put an X in those missing spots. All right. So for this first one, we need to use Pythagorean theorem. 24 is the hypotenuse, so it goes by itself. So, I'm sorry, x squared plus 21 squared equals 24 squared. And we will use our calculator to get x squared plus 441 equals, and 24 squared, 576. Subtract your 441 from both sides. Your 441's cancel, and we get 576 minus 441, that's 135. And now we take the square root to find that missing side. Now let's see. Okay, so we get x equals. I know that 5 goes into 135, so I'll do that first. 5 times, and we get 27. And now I can break 27 down into 3 times 9, or 3 times 3 for the 9, times 3 for that leftover 3. 3 to the 3rd power, 3 times 3 times 3 is 27. For every 2 3's, a 3 comes out. 3 comes out, 2 of them gone. There's a 5 and a 3 left. Multiply them out. So here is your missing side. If I asked you, is it a Pythagorean triple? Not a Pythagorean triple, because this side has a radical. All right. Next one. Again, here's the missing side. 4 is my hypotenuse. Remember, we identify that first. So x squared plus radical 7 squared equals 4 squared. Remember that the square and the square root just cancel. So we get 7. And that's 16. Subtract 7 from both sides. X squared equals 9, and we take the square root. And how about that? 9 is the perfect square of 3. And there's the missing side. Again, because of that square root of 7, we are not a Pythagorean triple. Okay, so there's Pythagorean theorem problems. Okay, so here's the 4th problem we'll do. This is from 9.3. Is the triangle acute, right, or obtuse? Okay, and we have the 3 side lengths here. Now remember, when you have these radicals, you need to figure out what they are, because the longest side has to go by itself. So the square root of 17 is 4.1. And 2 radical 3 is 3.46 or 3.5. So notice, they're all kind of close, but this is the longest. That's the longest side. Okay, maybe I should do a different color, right? So we did 4.1. That is 3.5 rounded. So square root of 17 is the longest side. So it goes by itself. So we put 4 squared plus, and now be careful. Remember this 2 radical 3 in the calculator? I'll put another marking in a second. But how does that compare to the square root of 17 squared? Now, we need to remember, and I'll use green, that when you use this in the calculator, there's 2 sets of parentheses you have to put. Now, I said you might just be able to do it without a calculator if you can square both. Okay? Just do that in your head. 4 squared is 16. 2 squared is 4, and the squared cancels the square root, so it's just 3. 4 times 3, 12. Square root of 17 cancels the square, you get 17. 16 plus 12 is 28. How does 28 compare to 17? 28 is bigger than 17. Therefore, the 3rd side is not longer than the other 2. That means you're acute. Remember, equals is obtuse. or I'm sorry, equals is right. And if the two other sides are less than the third side, it's obtuse, because that means the third side is big. All right. So that's a acute, right, or obtuse triangle question. Okay, so here's the next two problems. Find x and y. All right. So if we look here at this first problem, we'll call it A. These congruence markings mean that these angles are the same. It's a right triangle. So this is a 45, 45, 90 triangle. I'll go ahead and label the sides. The legs are the same, z and z. The hypotenuse is z radical 2. They give me the hypotenuse, so I have to take, to find x, I have to take that hypotenuse and divide by the square root of 2, which means I have to rationalize 18 radical 2 over 2, and the 18 and the 2 simplify to 9 radical 2. So there's x. X is 9 radical 2, and for a 45, 45, 90 triangle, the legs are the same, so y is 9 radical 2. And that's the 45, 45, 90. Over here, we have a 30, we have a 90, so this has to be 60 degrees. Sorry about the orange. So this is a 30, 60, 90 triangle. So again, I'll label my sides. This is the short side, so that's z. Hypotenuse is 2z. The long leg is z radical 3. Now, if they give you the short side, it's great, but they didn't. But they gave me the next best thing. They gave me the hypotenuse. Hypotenuse is 14. To get to the short leg, x, I just take 14, and I got to take away this 2, so I divide. And we get x is 7. So there's x. X is 7. And then to find y, I take my short leg 7, and I multiply by the square root of 3. And there's 30, 60, 90. Okay, and that was problem B. All right, last problem coming. Okay, so here's the last problem. It's one of those drawing problems. So this one says, the altitude of an equilateral triangle is 6. So this is a 6 right here. Find the area. Okay, so find the area. All right. So you must draw a picture. You must draw an equilateral triangle. All sides the same. Here is my altitude, which is 6. So then from here, I'm going to pull one of the 30, 60, 90 right triangles with an altitude of 6. And I'm going to label it as x, 2x, and x radical 3. Now I want the area. So understand, to find the area of this, I need the height and I need the base. Okay? So this is a 6, this is an h, and that's a b. Because area, of course, is 1/2 base times height. That's the area. So I have the height. So I know that the area is 1/2. I don't know the base, but the height is 6. Well, to find the base, what I'm going to do is use my 30, 60, 90. They give me this side with the radical. I need this side right here, x. Well, to find x, we take 6 and divide by the square root of 3. Rationalize. And we get 6 radical 3 over 3. The 6 and the 3 simplify to 2 radical 3. So there's x. This side right here is 2 radical 3. This part right here is 2 radical 3. Well, they're the same two 30, 60, 90 triangles, so that side is 2 radical 3. And as I showed in class, 2 radical 3 and 2 radical 3 gives you 4 radical 3. You add them. 2 and 2 is 4. The radical 3 stays the same. So here is my missing base. 4 radical 3. So to do this problem, we take 1/2 of 4 radical 3 times 6. We're going to multiply 4 and 6 and get 24, and then take half of it. That gives me 12. So 12 radical 3 would be the area, or in the calculator, 20.8. So remember, for an equilateral triangle, you use a 30, 60, 90. If I were to have given you a square, remember that when you draw the diagonal, you get 2 45, 45, 90 triangles. So a square leads to a 45, 45, 90. Okay, so this test is not, this quiz is not easy. So make sure you study. and come in prepared. All right, thanks for watching.